So now let's look at solving applied problems. The horizontal distance a kicked ball will travel in the air, ignoring air resistance, is given by the equation r of theta is equal to v sub 0 squared times the sine of 2 theta all over g, where v sub 0 is the initial velocity of the projectile, theta is the angle of elevation in degrees, and g is acceleration due to gravity, and that's 9.8 meters per second squared. So here's the question. The average person can kick a soccer ball with an initial speed of 60 miles an hour or 26.8 meters per second. At what angle of elevation should the kick be directed to travel a distance of 60 meters before striking the ground? So the question on this one I'm going to underline because I want to keep my focus on that. I am looking for an angle of elevation. And we know that theta is the angle of elevation. So I am solving for theta. Now I'm going to go through and see what else can I substitute in. The equation is r of theta. V sub 0 is the initial velocity, which is equivalent to speed. And I'm being told that speed is 60 miles per hour or 26.8 meters per second. I'm also told that g, gravity, is 9.8 meters per second. I would say since gravity is given to me in meters per second that I will probably use my initial speed also in meters per second. So I'm going to use the 26.8. So let's see. And then I want to find out what angle should I kick the ball so that it's traveling 60 meters. So I'm talking about a distance of 60 meters. And what is distance? Well, the original problem says that the horizontal distance that a ball will travel in the air is given by this equation. So horizontal distance is what this whole equation is equal to, and so in that case horizontal distance is my r. So let me substitute in. I'm going to have 60 is equal to my v sub 0, which I'm going to use as 26.8 squared, times the sine of 2 theta all over my g value, which is 9.8. And if I can solve this equation for theta, then I think I will have my answer. So let's go through the process of solving for theta. Theta is inside the sine function. So before I can even talk about the solving for theta, I need to get the sine function by itself. So I'm going to use some algebra here. I'm going to multiply each side by 9.8. And that is going to cancel that, so that looks better already. 9.8 times 60, if you use your calculator, is equal to 588. And 26.8 squared. Let me just go ahead and move this over. I'll show you step by step. So now I would divide both sides by 26.8 squared. And when I do that, I think that will get my sign by itself. Now I have a feeling I'm going to get a decimal approximation. If you put 588 divided by 26.8 squared into your calculator, what do you get? Well, first off, you need to, well, let me see. Let me go ahead and just plug that into my calculator. I got around 0.81866. And I'm not sure how far out to take that, but if you have a calculator like I do, you're probably going to use more decimals than that. I actually got 0.81866785848. So that's the number I'm going to use in my calculator, but because I don't want to write all of that out, I'm just going to write what you see on the screen down for now. Now I need to get the 2 theta by itself, so I'm going to take sine inverse of each side. And while I'm writing this down, I want you to think about, should I be in radians or degrees? So the question says, at what angle of elevation? So do I want to express that angle in radians or degrees? In a word problem, I usually say express it in the way that makes the most sense to you. So even though I like radians, in my common everyday life, I would probably talk in terms of degrees. So I'm going to make sure that my mode is set to degrees. And when I change that and I put sine inverse of 0.81866 into my calculator, let me just move up here, I got 54.95, and that's degrees. And then, of course, I know that on top of that are multiples of the period, which is 360 degrees K. And that's what 2 theta is equal to. Now, if I divide both sides by 2, I am going to get 27.5 degrees plus multiples of 180. Now, before I do any more, let's remember that this answer of 54.95 degrees that the calculator gave me is just one of the possibilities. 54.95 degrees is in the first quadrant, which makes sense because it had an output for the sign of a positive number. But the sign can have an output of a positive number, not just in the first quadrant, but also in the second quadrant. So another possible answer for this problem would be taking 180 degrees and subtracting out 54.95 degrees. Oops, I already divided by 2. I'm getting ahead of myself. Now let me divide by 2. And if you put into your calculator 180 degrees minus 54.95 degrees, I got, let me see, what did I get? I think I got 62.5. Double check me on that. Okay, so at what angle of elevation should we kick the ball? Now, assuming you're kicking the ball, probably you're kicking the ball and the angle is going to go anywhere from 0 to 90 degrees. So even though I did the algebra correctly by putting the 180 degrees K, I don't think it's going to be relevant in this problem. So I would say at what angle of elevation should the kick be directed to travel a distance of 60 meters? I would say the kick should be directed either 27.5 degrees or 62.5 degrees. Okay, so we've answered the first part of this question. The average person can kick a soccer ball with an initial velocity of 60 miles per hour or 26.8 meters per second, and the angle of elevation that they should kick should be directed to travel a distance of 60 meters before striking the ground. We got that the angle of elevation should be 27.5 degrees or 62.5 degrees. Second part of this question says to graph the original function with v sub 0 equal to 26.8 meters per second and verify your previous answer and to determine the maximum distance that you can throw the ball. So what we're going to put into our calculator will be y equals, and then I'll put that v sub 0 in, so 26.8 squared. I will put the sine of 2 theta. Depending on your calculator, if you're using Desmos or GeoGebra, maybe you'll use x instead of theta. That's okay. And you will divide by that 9.8. That will be one of your equations. And then we want to see when does that equation give me an output that's equal to 60. So go ahead and take a second and put that into your calculator. I'm going to suggest that you think about this a little bit before you move on in terms of, do I need to have my device, my graphing device, set to radians or degrees, and then what sort of window should I have? In other words, my x values, what should those look like? So let's answer some of those questions. First of all, we should be set at degrees. My x's, remember those stand for angles. Those stand for angles. And because I'm not expecting to kick behind me, I'm going to say that I probably am only interested in maybe 0 to 90. And then my output, y, represents a distance, right? Distance. And we already know that 60 is going to be one of our values. So maybe we will just make it something bigger than 60. I'll just guess it maybe 100. And I think that that will sort of make the graph that I get a little bit more manageable. So go ahead and pause the video, do that for yourself, and then come back and hit play and you will see what I got. All right, so here is the picture that I got, and we want to answer this question. The parabola that you see in blue is my graph with the 26.8 substituted in for v sub 0 and 9.8 substituted in for g. And then of course we were interested in when is r of theta equal to 60. And I don't show that picture on here, but I can sketch that in pretty easily. That's going to be a horizontal line going through 60. Now, do you remember what our answers were? Let's see if we got those right. Where these guys intersect is what I would expect to see as my answers. I said one of my answers was 27.5. Does that look like a theta of 27.5? I would say, yeah, pretty darn close. My second answer was 62.5, and if I follow this down, the intersection, if I follow that point down, it does look like 62.5, so I'm pretty happy with that. The second question says, verify your previous answer. We did that, and determine the maximum distance that you can throw the ball. Well, notice that I've labeled the axes here. Theta, of course, is my angle on the horizontal axis, and then distance in meters is my y value. So the maximum distance would be the vertex of this parabola. So whatever I think that that point is. Depending on what type of graphing device you're using, if you're using Desmos, you're just going to click on that parabola and, well, it's not a parabola, but it looks like a parabola for us, and it will tell you what that maximum point is. I can also just eyeball it here. It looks like it's occurring at a 45-degree angle is what I would say. So the maximum distance is how much? Let's see, so what is that value? It's just right before 75. So you can use your graphing device to come up with an exact answer. I'm going to guess that it's around 72. So the maximum distance is going to be 73 meters, and that's going to occur when I kick the ball at a 45-degree angle.